In question 5 of the 2020 VCE exam, the information given looks a little different to the normal kind of information given to work on earliest starting time and the latest starting time questions. So let's look at it. The Sunny Coast Cricket Club Room is undergoing a major works project. This project involves 9 activities, A to I. The table below shows the earliest starting time and the duration of each activity in months. So the immediate predecessor is also shown, and so this is the column for the immediate predecessor of the activities given here. And the very first question asks you, the information can be used to complete a directed network. So maybe they do expect you to draw a network. This network will require a dummy activity. Complete the following sentences by filling in the boxes provided. The dummy activity can be drawn as a directed edge from the end of activity box to the start of activity box. So I look at all the immediate predecessors, and the only ones that I can see have alphabets in common is this one and that one. And the rule for a dummy to exist, see the B is common, okay, is that it should be, the dummy should exist from the end of activity B to, which is the shared activity, to the beginning of the activity that has multiple predecessors. So which means that of these two activities, the one with multiple predecessors is C, because it has two predecessors, A and B, whereas activity F has only one predecessor. So from the end of B to the beginning of C, the activity that has multiple predecessors. Activities C that has multiple predecessors, A, comma, B. So it would be good to actually remember this rule, and this immediately will help you start a network without delay. Okay, so let's now try and draw a network. Now A and B have no immediate predecessors, so we can actually assume that they are the beginning edges from the start. And the duration of activity A is 2, and the duration of activity B is 5. And then we know that C takes off from the end of A and B. So that implies, and we know that the dummy goes from the end of activity B to the beginning of activity C. So we can actually introduce a dummy here, end of B to the beginning of C. Now the direction of the dummy has to be very important, and the duration of the dummy is 0. So the arrow is important, and you have to write D comma 0 next to it, okay? And D starts from that point at the end of A. So basically we can see that C has not only A as a predecessor, but also B. The dummy connects a particular edge without making parallel edges, okay? So that is C, and the duration of C we don't know. Now, so we have drawn C. Now D takes off from C. So let's say that was the vertex here. D takes off from, and the duration of D is 7. Okay, so that's done. E takes off from C. Now E taking off from C, but we can also see that E also joins here. Okay, so E takes off from C and so does D. And then E also is the predecessor for I. So I'll leave E for the time being and go to F. F takes off from B. So F takes off from B and the duration is 3. And G takes off from D. Now I can see that E and G join together. Now E is from C and E and G join together with a H. H takes off from the F that we've drawn. So let's draw H of duration 9. Now E, G and H are the predecessors for I. So clearly I takes off from H. But they say that E, G, so where does E take off from? C. And so we can draw that as an E. And E is 9. And G takes off from D. And G is 4. And activity I duration is 2. And that is the network. And so we can say it finishes here, okay? So the question is now, what is the duration of activity C? Firstly, let us complete this box from the end of activity B to the beginning of activity C. You have to be careful not to write C to B, because from the end of activity B to the beginning of activity C. And the next question says, what's the duration in months of activity C? Now, in order to calculate the duration in months, it's important to look at the table. The table actually has enough information for you to be able to calculate what it could be. Okay, so we know that as we do the critical path basically will be got by adding the earliest start times to duration to the earliest, and we get the earliest start time of the next activity. Okay, so because the earliest start times have been given and the durations, let's say I start off with earliest start time of A being 0, and if I add the duration of 2 to it, that does not give me another earliest start time of 2 on the table. So instead of that, maybe A is not on the critical path. Let's look at B. 0 plus 5 looks like, yep, there is a 5. Okay. Now 5 plus the activity. Now if we look at what could after, so 0 plus 5 is 5. Now 5 plus something will give you 7. And what I can see is if I took 7 plus 7, okay, so, and if I took 7 plus whatever this is, 7, and if the duration is also 7, I should get the next earliest start time to be 14. If instead I had gone here, so though I can see a 14, but if instead of this 7, I had gone to this 7 and I had added 7 plus 9, and that would be 16. I can't see the next 16 in the earliest start time column. And if I had gone to 5 instead, 5 plus 3, 8, I can see 8, but when I do 8 plus 9, I can't see a 17. So it's important that you look around at the table and see the earliest start time plus duration should give you another early start time. Okay. So I will go to this box and that plus 7 gives me 14, and 14 plus 4 gives me 18, and 18 plus 2 must be the minimum completion time. And that tells me that this activity must have been 2. And so this must be 2. And that, what's the duration? The answer is 2. And because they've said in months, you don't have to write months. Name the 4 activities that have a float time. What I have drawn over here in terms of arrows on the table is actually the critical path. So if you ask me what is the critical path will be B leading to C, leading to D, leading to edge G, and leading to edge I. So the activities not on the critical path will have float times, and those are A, E, F, H. So the answer here is A, E, F, H. The project to be crashed by reducing the completion time of one activity only. What is the minimum time in months that the project can be completed in? So in order to answer this question, it's easier if you actually draw the activity network, as I have done. And let's start by doing the forward scan. So we start with 0 over here, and 0 plus 2 is 2. I don't write 2 in the box over here because I can see that at this point there has to be a choice made. There's a choice that's got to be made here. There's a choice that, yeah, those are the 2 places. And so because we have to make a choice, I write it here instead. And then I come along B, and 0 plus 5 is 5. And then the dummy is 0, so 5 plus 0 is 5. Now the larger value being 5, because we're doing a forward scan, let me write 5 here. Now see, 5 plus 2 is 7, and 7 plus 9 is, again, we're coming to an intersection point where 3 edges are meeting, so we don't write it straight away in the box. So 7 plus 9 is 16. Now let's come along F. Earliest start time of F is 5, duration is 3, so 5 plus 3 is 8. And 8 plus activity time of 9 for H is 17. Now let's go along D, because there are 3 edges that meet over here before we make a choice. Let's go along D. Earliest start time for D is 7, and 7 plus duration time of 7 is 14. And 14 plus 4 is 18. And of all these 3 values, the largest value is 18. And so I'll write 18 in this box. Now going along I, 18 plus 2 is 20. So when we do a backward scan, we start from this end, 20. 20 take away 2 is 18. And as we do a backward scan, the places that we actually are going to be making a choice are, we go backward here and we go here. So we'll be making a choice here. We'll be making a choice here. and we'll be making a choice here because we're going in opposite in the direction of arrows to where multiple edges meet. Okay, so let's start again. 20 take away 2 is 18. Going along G, 18 take away 4 is 14. And then 14 take away 7 is 7. Making a choice, so write it here. And then again back to the 18 over here. Going along E, 18 take away 9 is 9. The smaller value, because in a backward scan you take the smaller value, is 7. And then along C, 7 take away 2 is 5. And 5 take away 2 is 3. So now let's go along H. 18 take away 9 is 9. 9 take away 3 is 6, but we can see we need to make a choice as multiple edges are meeting here. And now let's come along from this part, the latest start time of C, along the dummy. And so that is 5 take away 0 is 5. Because we're going opposite in direction to the arrow. Now, of the two values, the smaller value is 5, and 5 take away 5 over here is 0. Now, the minute you get a 0 on one of the edges, initial activities, it usually means you're right. Okay. So now let's look at it and see which activities, when reduced, one activity when reduced will reduce the minimum completion time. So the project can be crashed by reducing the completion time of one activity. Now, according to this table, the critical path activities are B, C, D, G, and I. And I've highlighted them in yellow over here. Now, what that means is if you add, 0, which is the initial earliest start time, to 5, you get 5. Both the boxes are the same at the end of B, and then go along the dummy. And so there 2, it's 5, 5, and then you add C of duration 2, you get 7, 7. And then you go along D, you add 7 to 7, you get the two boxes 14, 14. Go along G, you add for earliest start time of 14 to 4, you get 18, and both the boxes are the same, 18, 18, and to 18 you add 2, you get 20, and both the boxes are 20. So where the boxes are the same, but you should be careful. The criteria is not that the boxes should be the same. Earliest should be equal to the latest start time. Criteria should also be that if you go add the earliest start time to the duration of the activity, you should get the earliest start time of the next activity. Okay. So on seeing that, now if we were to reduce a particular activity that could change the minimum completion time, it should be one of the activities on this critical path. Now let's see which of these activities, if we reduce, we can actually make a